Welcome to solverfy.
Hello student. So the first part of the question is to calculate the grams of caffeine per kg of soluble coffee. So here in step 1, so to start the question, from step 1 we'll calculate the concentration of caffeine in the final solution. So here we have been given the first solution which is prepared from 12.5. So here in solution 1, the sample amount was taken as 2.5 gram and it was diluted till 500 ml. So let it be the concentration 1. So the concentration 1 is equal to 2.5 gram divided by 500 ml. So it is equal to 5 milligram per ml. Now in second solution it is prepared from 250 ml of the first solution, then it is diluted to 500 ml. So it has taken 250 ml from the first solution and then it was diluted to volume 500 ml. So now the second solution, for second solution the concentration, let it be C2, and it is equal to C1 into V1 upon V2. Since this is from M1 V1 is equal to M2 V2. So from this, using this formula we can calculate the C2. So let's put the value over here. So the C2 is equal to 5 milligram per ml multiplied by V1, which is 250 ml. 250 ml divided by 500 ml. So by calculating, we'll get the concentration after dilution, which is C2. So the C2 is equal to 2.5 milligram per ml. Now we will be calculating the mass of the caffeine in final solution. So which is equal to the C2 multiplied by the volume. So here it is equal to, so the concentration is 2.5 mg per ml multiplied by, so here the volume of the second solution is 500 into 500 ml. So here the mass of the caffeine is equal to, so the mass is 1250 milligram. So in gram it will be 1.25 grams. So this is the mass of caffeine in second solution. Now, so in step 3 we will be calculating the grams of caffeine per kg of soluble coffee. So here the grams of caffeine per kg is equal to, so it is equal to 1.25 gram divided by 25 gram, 2.5 gram, which is the concentration, multiplied by 100,000 gram per kg. So this is the concentration, which is C2. So it is, so here the 2.5 gram is the soluble coffee which was initially soluble. So it is multiplied by 1000 gram per kg. So the grams of caffeine per kg is, which is soluble, is 500 gram per kg. So this is the answer. Now let's see the second part of the question, which is, so the second question is to calculate the transmitted light, the fraction of light transmitted. So we have been given the absorbance value, which is 0.510. So we will be using T, the formula where T is equal to 10 raised to the power minus of absorbance. So let's put the value over here and let's calculate the T, which is transmitted fraction of the light. So it is equal to 10 raised to the power minus of 0.510. So the final, by calculating, will get the T transmittance, and it is equal to 0.301. So this is the answer. Now let's see the third part of the question, which is third part is to calculate the transmittance of light when the new absorbance is the 3 times of the previous absorbance. So let's calculate the A dash over here. So it will be 3 into 0.510. So it is equal to 1.245. So the new absorbance value is 1.245. So similarly, we'll use this formula to calculate the T. So the T is equal to 10 raised to the power minus of 1.245. So by calculating, we'll get the transmittance value. So it is equal to 0.039. Now the now to find the percentage of light transmitted, we'll multiply by 100. So here the percentage of transmittance is equal to 0.039 into 100. So it is equal to, so here the transmittance value is 3.9%. So this is the percentage of transmittance. I hope you find this video helpful. Thank you.